The given curve is rotated about the y-axis. Find the area of the resulting surface. The formula is given by s equals the integral of 2 pi x ds, where ds is the square root of 1 plus dy dx squared dx, or ds is the square root of 1 plus dx dy squared dy. Now let's take a look at an example. In example 1, suppose we're given y equals 1/3 x to the 3 halves, where x is greater than or equal to 0 and less than or equal to 12. Notice how y is a function of x, right? In other words, y is explicitly defined in terms of x, right? And my limits are in terms of x. So that means I'm going to be integrating with respect to x. So we need dy dx. dy dx is 1/3 times 3 halves x to the 1/2, which is equal to 1/2 x to the 1/2. If I take dy dx and square it, I get 1/4 x. So s is the integral from 0 to 12 of 2 pi times x times the square root of 1 plus dy dx squared dx. But remember that dy dx squared is 1/4 x. So s is the integral from 0 to 12 of 2 pi times x times the square root of 1 plus 1/4 x dx. But if we look at that radicand, that value inside the radical, we can take 1 plus 1/4 x and write it as 4/4 plus x over 4. And then adding them up, we get 4 plus x over 4. And so we get the integral from 0 to 12 of 2 pi x times the square root of 4 plus x over 4 dx. Now remember, the square root of 4 is 2. And so this 4 inside the radical can cancel out this 2 over here outside the radical. And what we're left with is pi times the integral from 0 to 12 of x times the square root of x plus 4 dx. To evaluate this integral, we're going to let u equal the square root of x plus 4. That's the key right there. Square both sides and we get u squared equals x plus 4. Solving for x, we get x equals u squared minus 4. dx is 2u du. Now, when x is 0, I'm going to plug that in to this first line. When x is 0, solving for u, I get u equal 2. When x is 12, 12 plus 4 is 16. The square root of 16 is 4, so u equals 4. So s equals the integral from 2 to 4 of pi times u squared minus 4 times u times 2u. Next page. So this is 2 pi times the integral from 2 to 4 of u squared times u squared minus 4 du. Distributing the u squared, we get 2 pi times the integral from 2 to 4 of u to the 4th minus 4u squared du. Integrating, we get 2 pi times the quantity 1/5 u to the 5th minus 4/3 u to the 3rd, evaluated from 2 up to 4. Now, I'm going to replace u with 4 and get a value, and I'm going to replace u with 2 and get a value, and then subtract. And that's what I did on this last line here. So applying the fundamental theorem, I get 2 pi times the quantity 1/5 times 4 to the 5th minus 4/3 times 4 to the 3rd minus the quantity 1/5 times 2 to the 5th minus 4/3 times 2 to the 3rd. Okay? Now, on the next page, I do some arithmetic manipulation. And when I'm all said and done, you're going to get an answer of 3,712 pi over 15. So the previous 3 lines is just arithmetic manipulation. In example 2, suppose x is the square root of a squared minus y squared, where y is greater than or equal to 0 and less than or equal to a over 2. Now this time, x is a function of y, and I'm going to have y limits instead of x limits like I did in the previous problem. So what I need is dx dy. And I claim that dx dy is negative y over the square root of a squared minus y squared. If I square both sides, I get dx dy squared is y squared over a squared minus y squared. So we're doing a little bit of the hard work initially. If I take 1 plus dx dy squared, I get 1 plus y squared over a squared minus y squared. Getting a common denominator, I get a squared minus y squared over a squared minus y squared plus y squared over a squared minus y squared. And notice how these y squared terms end up canceling. And what we're left with is 1 plus dx dy squared is equal to a squared over a squared minus y squared. Now, plugging this in, and then we also don't want to forget x is the square root of a squared minus y squared, okay? So s is 2 pi times the integral from 0 to a over 2, because remember y is wedged in between 0 and a over 2. So 2 pi times the integral from 0 to a over 2 of x, which is the square root of a squared minus y squared. So don't forget, we're integrating with respect to y. So this square root of a squared minus y squared guy, that's another name for x. And I'm going to multiply that by the square root of a squared over a squared minus y squared. And remember, a is greater than or equal to 0. So I can freely say that the square root of a squared is really a. And so this is 2 pi times the integral from 0 to a over 2 of a dy. Because square root of a squared minus y squared will cancel out square root of a squared minus y squared over here. And that's literally what we're left with. And so this is 2 pi times a over 2. 2's cancel, and we're left with pi a squared. And that's example 2. And that'll conclude this video. Okay, thank you.